So Bruno, I mean, Bruno has been, I don't know how many years.
How many years? A decade.
So it's Bruno, and we don't recognize Bruno today because he doesn't have his hat. So it's
yes, it's here. No, it's here. But the problem is that on the microphone is not compatible, so no, the helmet. So I keep the helmet. Sorry, it's a choice.
So Bruno is going to talk about performance automation. We can do it, and so it's pretty aligned with automation. There are a few things to consider: how to alert in case of performance issues, if the application is a freeze or whatever. I think this session could be very meaningful for you guys who wants to be starting to automate their performance practice. Otherwise, related to Bruno has been doing performance since 2002.
Exactly.
In France. He now working from Aero Performance, so it's called WAPSI.
Yes, we just changed of name.
And I like it. So if you know Scott Moore, he calls SWAT engineers. So in WAPSI, they don't have SWATs, they have ninjas and samurais. So people who's able to fight and figure out issues. So if you want to learn more, I recommend to look at WAPSI's LinkedIn page. You will have more details. All right, without waiting anymore, I'll let you start sharing your screen. And then I will get back to you for the Q&A session.
So you share my screen, that's it? So you can see my first screen. Okay. Is that good?
Not yet.
So you share my screen or I share my screen?
You share your screen.
Okay, so hold on just a second. Share the screen.
On the right side, there is a...
Yes, partage d'écran, okay. I've got only one screen, so... Okay, so you probably see my screen, and you see the first slide. Yes, thank you to invite me to this Back to the Future of performance, of course. It's a pleasure to wear the Marty jacket in red and to wear this T-shirt with my favorite DeLorean car. The idea today is to talk about a project which is a success story, a technological success story, because I would like to talk about how we could make automation with performance. There's a long history between what is functional test and automatization of functional test, and there's also a story about performance test. And today we have a way to link them, to join them by an automatization of performance test. That's what I'm going to show you in this presentation. Okay. First of all, I would like to talk about the functional part, which is understand. My problem was, is it possible to check continuous performance evolution of an application? And is it possible to guarantee availability of an application? Because many projects request to know if the application is still alive, but also if the performance is still good along the time. So they would like to have some kind of indicator, some kind of metrics to show, to report or to alert if the performance are permanent, good, and if the availability of the application is good. How can you answer that end-to-end activity is okay? So from the beginning of from every part of the application, we have to make some tests. And is there an evolution of response time? And you know there is a response time evolution during the time, sometimes due to network, sometimes due to load. So we can test that only with load test script and load test tool. And of course, how to be alerted about this difference, this movement of an application. So actually, there is some kind of solution, technological solution, which is able to test that. Because the first of all is monitoring of server and application. So the monitoring is just is something classical, you know it from a long time. But monitoring just guarantees that the server is up, and the application, the process is up. It doesn't guarantee anything more. So we have to go further, and to go further, exists actually in the RPM some synthetic monitoring, which is a tool who can replay a scenario and play it every 5 or 10 minutes to ensure that the application is up. So that's a good way. But program of synthetic monitoring is actually available only on web application. There is no so much synthetic monitoring available for IoT, for JSON, for all this kind of technology, of protocol. So it doesn't answer for every protocol. There is also the API and real user monitoring that you can deploy in other kind of APM, which is very interesting and useful because it gives you the real activity. But there is two problems with that. The first problem is if there is no user connecting, you don't know if the application is up or not. And second problem, if the service is KO, that's the same. You don't have reports about non-activity. So the real user monitoring can help you only on response time on network, but it doesn't help you about the application alive. That's it. My English is not so fresh. Sorry. So the idea is to go to load test and to use script load test in order to check off this functionality. So first of all, as you can see, there is 6 points in my presentation, 6 points that we must complete. First of all, it's to test the functionality, login, research, open a file, open a document, etc., etc. And to test that, load test script is the best way to test it, like a synthetic monitoring, but the load test script is able to do it. Second, availability. Does the application is available? Available in response time, that's a point, but available just technically. Does it answer when we ask for it? The load test cannot test, a load test script cannot test it himself periodically, so he needs another tool to help him. We will see it later. About the response time, this is a load test script job to know the response time of all functionality, so that's perfect. End-to-end test, that could be done also by the script, but I will not give you more details on it. It could be the point of a demonstration. So the tendencies is important. That's the evolution of response time during the time. So to do that, we need also to come back to the second point, availability, which means we need periodic run. And load test script cannot do it himself. And last of him, alerting. We need some specific development for alerting because load test script is not done to send some alerts and to work with production alerting system. Let's have an example, which is better. As you can see on the right down, there is Marty and Jennifer who would like to go to the lake with a 4x4. But to join the road, they need to update the navigation system in the car. And so, can we do it? Can we make a script who is doing the same? Admin updating a firmware on a car. So you're going to tell me that's not so usual actually to update a firmware on a car. Yes, but at the future it's going to be every car who's going to have a FOTA system that help you to upgrade your navigator, your browser in the car. Not the case, but it will be the case in the next year. So how to update a firmware dialog? A firmware. So the dialog is simple. First of all, the firmware connects the car connect to the server, the central server. Then it's sending the version of the firmware and telling, okay, actually I've got my firmware version 1.0. Do I need to upgrade? The server answer yes, there is a new version which is version 2.0. So a requesting for the package 2.0. After he's downloading the package to have it and to download inside the car. And so he installed the package, which is not a load test, but which that's a step. And finally, it's sending a new inventory to the firmware, to the server, telling, okay, now I've got the new firmware version, version 2. Okay, fine. This is the dialog and leaving the connection, of course. So this is a classic dialog of an upgrade of firmware that you have on your cell phone when you want to, you have an upgrade of application, but you will have the same thing on your car sooner, very sooner, you know. So how to do that? Is it simple? How to make some tests with that? We have the script that can replay this dialog. The script is easy because it's a HTTP classic script by a load test. And so this script is connecting to the application and doing the upgrade. But to manipulate the script, we need an engine, load test engine. So you see, I put a V2 engine, which is beautiful. And this engine will start the script and we will help the script to do the job, of course, with an injector, which is classical. I put a canon because I love the idea that the injector is aggressing the application. That's it. So the communication with the injector. So the idea to separate the engine and the injector is to tell that the injector could be in another area, and sometimes you can have several injectors to do the job. So finally, when the test is done, you can put the result of the test into a repository. Usually in a load test tool, the repository is inside, and you manipulate your result directly inside your load test tool. But let's have an idea that the load test repository is outside another database that we're going to manipulate after. So the load test engine will only work to launch the test and send the result in the repository. But we need a scheduler. That's the main part. And the scheduler will start the test, so give order to the load test engine to do the test and put the result in the repository. After, when the scheduler is finished, is also welcome to put the alert in the dashboard. So the scheduler will probably put the alert through a dashboard if we have a problem with the application. Let's see what are the steps. So if you see on my right of my screen, in green, that's the steps that we complete with my script, and in orange there is the functionality not complete. So the script makes the functionality test. That's okay, that's its job. You also get the response time, but you have the ability also to send some alerts, because the script is able to send API connection to make alert to a specific system, but also it can send mail or something like that. So the script has got the ability to send some alert, but is it its job? Probably not. But we keep it on site. That's why my alerting system is in bold with orange around it. The step 2, launch the run. That's easy. So we have a load test engine who launch the run and the injector will connect to the application. This step is easy to understand. And finally, store the result in the load test repository. After that, when the test is done, we manage it by the scheduler. He launches the run, of course, but he also probably launching the alert. That's why I put the alert here. So schedule the type and frequency, and I say type because I will explain later that there is different type of test, and also choose a frequency of runs of the runs. Put the information to the dashboard, step 4. So you see on my right, all the functionality are green now. But as I told you, the alerts could be sent by the scheduler to the dashboard, but also from the script. Okay. Now, let's see which kind of script is it interesting to manage for this kind of tool. The first of it, the main script, is the script who tests the application. So that's the script that I showed to you, the script to connect, test the response time of the application, and after sending the result to the repository. That's fine. But this kind of script is not, that's the art, but we probably need something else. We need a script to analyze the result. So I just told you the script will bring a response time and probably could send the warning if they have SLA created, but it doesn't activate this warning. So we can use another script to analyze the result in the database. Why? It can analyze if there is some warning on the response time on the last run. It can also analyze if the last run was not too distant from the run before. If we decide to have a run every 5 minutes, if there is a script checking if the run goes every 5 minutes and suddenly there is no run for 6, 7, or 10 minutes, that's probably there is a problem with the last run. So we can send an alert about it, which is an alert probably on the performance, but also on the tool who send the script. So it's an alert of 2 levels. It can also check the response time, I told you, and it can also finally send information to dashboard and to be intelligent with the dashboard. Because when we send information to a dashboard, you can send an alert, but you can send a stopping alert. We'll see it just later. And finally, last script could be maintenance script. What to do? Do we must care about the maintenance? Yes, because we can pull a database and with many runs, and probably we don't need to keep so many information about all the runs of the last year or so. Probably if we keep the runs for the last 3 months or last 3 weeks, it's enough for your alerting system, because we just want to have some alert and not have a full history of what happens in this application. So that way we can create some script of maintenance, so we can clean the database and also clean some data inside the application, because probably sometimes we need to set up some data and to remove some data in the application to be sure that our main script is working perfectly. So first step, we need to launch the main script. Second step, we send the alert, and third of it, we pass the maintenance. So now that everybody understood what is it, let's see the technical part, because the functional part was very interesting, isn't it? So about the technical part, how to do? I've got my functionality. Which tools can I use to implement that? For the script, I put my script into GitLab. Yes, GitLab is something new but easy to manipulate, and so you can put your script into GitLab because the access is easy to do, and you can make a maintenance of the script from outside. If you have an upgrade about your script, that's easy. Or about your SLA, which is in the script, probably. Second of it, for the load test engine, look, I choose a controller. So here in my presentation is a Neoload controller. So the controller will be only to make the runs and need an injector. So the injector is a Neoload injector. But you tell me, okay, that's the same product, the same place. You will see just after that's not the case in my demonstration, in my presentation, sorry. The last one, for the repository, I use a Neoload Web, which is a stack of 3 applications combined with MongoDB. It's delivered actually only on Docker. So you can use this microservice. As I told you, it's a stack of 3 applications, front Neoload Web, back Neoload Web, and MongoDB. Inside MongoDB or outside MongoDB, etc. But that's the place we're going to put repository. The advantage of Neoload Web is it's got API accessed that you could access from the outside, and we can send some scripts to request information to Neoload Web about the last run or about the last 10 or 100 runs. So we can have information about what happens in the repository easily with only JSON request. For the scheduler, I think that you imagine which one I'm going to present to you. Ta-da! My scheduler. Jenkins. Oh, clear. Okay, Jenkins is the most easier tool to use as an orchestrator or scheduler, actually. So if you need to create this kind of little bench, it's easier to use Jenkins and is fully compatible with Neoload, and it's got a plugin to start Neoload. As a dashboard, there is many solutions because you can send mail, of course, but you can publish on a dashboard like Slack or like Trello. So we make some exercises to publish in one or another, and that's very easy to configure, to develop. So there's many dashboards. So it's up to you to choose which kind of dashboard you want to use, and depending of the enterprise dashboard alerting systems that they use usually. So it's just a question of your enterprise environment. That's it. Alors, as I told you, Neoload Web exists only on Docker, but Neoload Controller also, Neoload Injector also, Jenkins also, and GitLab also. So you can put everything in one Docker. And Slack, Trello, etc. that's outside. So just to finish on this, you put everything on a Docker. Docker usually is working on Linux, but you can work on Windows, but it's better on Linux. That means that in one small VM, you could deploy a Docker and deploy all of that to have a product, a demonstration product, easy to manipulate, to install, and to present to your client or to your responsible. That's it. So just have a look because we keep talking about technical. Just have a look about Jenkins pipeline command line because that's the heart of the tool. Jenkins is inside Docker, but is also starting the Docker microservice that you need. So first of all, is starting the controller, and in the controller, so as you can see, he's calling the controller. In the controller, is requesting for a project. That this project is in workspace. Workspace is a variable going to GitLab. So he's requesting for GitLab. Then he starts a continuous performance project scenario with a number of builds. It's going to be the names that we publish in Docker, not in Docker, in Jenkins. It starts with no GUI, of course. We launch the scenario continuous performance. Then we also need an injector that we call from the workspace. So that's an outside injector, which is started with a YAML. I can show you after the YAML if you want during the question. And finally, we need a token to talk to the Neoload web repository, and we have the API to request for the license in Neoload web. That's it. So then Marty can run. We have all the run turning every 5 or 10 minutes if we want a performance run. Stage of Docker, just a little bit of information about it. Docker is something quite new, 5-8 years, very interesting because we can manipulate microservice. Now we manipulate with Kubernetes, Pivotal, etc. But as an example, we have this part, the permanent microservice in Neoload Web, MongoDB, Jenkins, and GitLab that always started. They are working every time, and they are always able to access. Sorry for my English. But when we start a run, Jenkins requests to Docker to start the controller and the injector. So during the period of a run, probably 30 seconds, 1 minute, 2 minutes of a run, of a single run, he starts this microservice and so close it just after. Goodbye. So you free memory and you come back on your permanent microservice. That's interesting, is that because with this system you don't use so much memory and so much CPU, and you can start several scripts in parallel. All the scripts will start their controller and their injector, depending the license, of course. So this way of working gives you a total liberty to deploy 5, 6, 10 scripts in parallel. After you just need some power and memory in your as you say, when there is multiple Docker bursts in your Docker application. And so it runs, it flies in this case. Let's see what there is after. This is a dashboard of probably some of you know the dashboard that you can find in the Neoload web. So every green peak is a run, and with this response time. And as you can see up of it, I put a red square to show there is 100 run in this dashboard. So you see the tendencies of evolution of response time. And you also see there is one which is red on the right, which means it's got an error during the runs. So this information is in Neoload web. Now let's get to find it, to check it, and send alerts. As I told you before, first we make the run, and after we're checking for the alert and problem and sending alert. So we could interrogate Neoload web with REST API, as you know, and which is very easy because it's got a Swagger, so very easy to implement. And with that, you can access to all your run, all the success, and there is also a part in the API telling if the run is okay, passed or failed, and so that's very easy to know if you have a succeed run or not, and to start an alert with that. Okay, so that's just a board, but the API is more interesting than the board, but I don't show it here because that's just coding. I will just to have a little look on the script here to show you the script of alerting, which is not the script of a run classical to make the download of a package, of a photo package. No, that's the script of alerting, just to show you that it is easy to develop because we manipulate only, as you can see here, some kind of JSON script. So it's only a REST API to interrogate the Neoload web, and after we can send mail and to Trello or to which one is it? Trello or the other one, Slack, to Trello to Slack with another request with a webhook. This one is Slack hook. Wait, this is Slack. So a request to Slack is only smaller than that, so it's easy to send it. So after you have the request arriving here, saying hello, I'm the robot. I make the test and the text have an error. You can click on the link to go directly to Neoload web to see the error into Neoload web. So the alert gives you also information to get back to your repository, etc., etc. That's it. And to finish, which kind of alert can we send? So I just tell you, but I will repeat a little bit. First of all, performance degradation. See the performance degradation, you need a SLA because my alert system doesn't know which is a level. So inside Neoload, you have also SLAs that you can implement. You can modify your SLA with Neoload as code. You can modify your SLA by the end and update your GitLab, etc. But so you can have a SLA inside the script, and so if the SLA are not too big, if the response time are not so good, you have in Neoload web alert directly from the run. You can also make an alert if you have an error 500, error 400, etc. And you can also check if the last run passed under the period that you decide, which is 5 minutes for me. So make an alert of this kind of problem. If the run doesn't pass before 5 minutes, you send an alert telling, take care, your alert, your periodic tools probably doesn't work anymore or have a problem of connecting, which is a real problem. Is it a problem from the periodic tool, or is it a problem of the application? But you have an alert, you can test just behind. So which kind of alert can we send? As I told you, we can send a pure mail, depending on the company alert system that you want to have. You can send a message to Slack by webhook, and you can make an evolution in a dashboard of Trello, which is so fun because you have everything in green, and if you have performance degradation, you put a box of Trello, you put it in another column, and you change the color of the box. You say telling that it's going from green to orange, and if they run after there is no more problem, you can tag back your box and bring back in green, so you can see the evolution of alerting directly on your Trello. Excuse me. You can also use other kind of API tools. This is not the point here. For sure, you understand how does it work. So let's talk about a little bit business. Okay, who could be interested about this performance periodic run? An agile project manager, that application, and he would like to be sure that make a continuous integration, so he would like to associate it with a continuous testing. That could help him for regression testing, but not only with functional tests, but also with performance tests. That could help him also to sizing, because you can see the response time degradation during the time that you load a database. Okay. A project manager in production, because at the beginning I talk about development, now I talk about something in production. So a classic application monitoring with emergency alerts. Your application is falling in production, just react. So that's probably the most interesting. Responsible of network and infrastructure. Usually they use IPM or something, they have other kind of alerts. But this kind of people like to know there is degradation of response time due to network or something like that. And so they love to be alerting in real time about response time degradation before the user calls them on the phone. And finally, SaaS manager, which must host an application online and would like to prove to his customers that the application is always up in order to have KPI, and because sometimes it can have taxes, how to say, they can have problem, and yes, taxes if the application is not up and running every time. So you need the baseline to guarantee and sort of an availability range, an availability 95% of availability, and so you can calculate with this kind of tool. I think that's all. Okay, is there any question, or do I go too fast? Oh no, it's time. I think it's good.
No, it's time. It's Q&A. You are.
Do I stop to share my screen?
No, you're very respectful with the timing, so that's awesome. You deserve
okay,
your jacket.
I stop the sharing.
You deserve your jacket because you're respecting you. No, so thanks. I noted down because you said you're making the call to Slack. Just for those who are not familiar, so this is going to be a Neoload discussion here. You can configure webhooks as well, so Neoload can also send a notification in Slack in case you need it. And the routing, so I don't know if you use the latest version of the API. We have the event API. Sorry?
No problem of latency. Sometimes I don't hear. No, just if the question is about the alerting dashboard, just know actually we work only on Trello and Slack, but there is many and mails also, sending mails. But there are many kind of dashboard or applications that you can address with API. And as I show in the presentation, the API could be addressed directly on the script or could be addressed by Jenkins. So we must be intelligent to know which one is there to send the alerts, which one is the job to send the alert. That's it.
So yeah. So I think my point was, did you hear me?
Yeah. It's good. Sorry.
There is an SLA API in your web and an event API. So you can imagine to run your test and having a third component that basically scan the events. Events could be an error, it could be SLAs. And you can even imagine to have a service running. So the service wake up when he receives a webhook. So let's say you configure Neoload Web to say, please alert that third-party component when the test is running. So every time there's a test running, your component will get from the payload the test ID and everything. and you will start parsing the events and the SLAs. And when you have something, you can imagine to throw the alert on the Trello or whatever. It's a way to avoid putting the alerting mechanism within the scripts, because if you want to switch from Trello to, I don't know, to another tool, you have to touch the script, so that's could be painful. That's what was my note. There is a question from the audience. It's a question from Anthony Perry, and the question is, why do not use the built-in GitLab planner instead of Jenkins?
Because I don't have, never use this lab planner, so we start with Jenkins because Jenkins is able to talk with Docker, and it helps us. At the original, we was working with Jenkins Neoload module plugin, Neoload plugin.
Yeah.
And so it was the beginning of our bench, but after we changed of way, so now we're just addressing by command line, which is not use the Neoload plugin. It doesn't matter, but so we keep on Jenkins, and we've got enough experiment on Jenkins, but maybe GitLab could help us in this kind of business, but I don't have experience on GitLab. On GitLab, so that's why we don't use it. But let's have another demonstration with it. Why not?
Yeah. All right. So now we have 20 minutes left to build that demonstration. Let's go. And I know that GitLab has all the components to do the same thing than in Jenkins. I'm pretty sure that what you have done with Jenkins could be delivered directly with GitLab for sure. Rob? Do you have any questions?
Yeah. Nice hat. Where do you run this? Do you run it in a test environment or production or both? Where do you see the tool being run?
Actually, we're working on a staging environment, which is a pre-production environment. We are working to Renault to test the application delivery for Renault, and so we create the same tool in the production environment, but it not depending of me, but it depending of Renault SI, and Renault SI is a huge company, and so they take a lot of time to deploy Docker, to configure Docker. So my prototype is working very well, and Renault is probably ready to create it, and they had a lot of procedure to create the same environment for production. So it doesn't depend of me, it depends of them, and they will. That's it.
And how do you keep your scripts up to date? Is that an automatic process, or is that still a manual bit?
There is a lag. Could you repeat the question, please?
Yeah, sure. So how do you keep your scripts up to date and things like that? Is that a manual process, or does that happen automatically in some way?
Okay, actually, we're working on an application which has no upgrade. This application, so we don't need to upgrade the script. Actually, we make all the script maintenance on manually, but we start to make some maintenance with Neotys code because we plan to deploy this kind of script in several countries, and all the countries have the country code to change. So we probably have probably need to have a single script work on different countries, and so the deployment we need to take the script and modify it at the fly in order to be launched in different countries. So there will be a Neotys code modification at the starting of the script.
Cool.
We hope so.
Yeah. That was a great talk. Thank you. I like the use of Docker for the agents.
And yeah, just one more question, Bruno. Do you use Docker, pure Neoload Docker containers, or do you use a Docker containers having Jenkins slave plus Neoload?
No, it's pure Neoload Docker container, downloaded from hub. So that's a pure Neoload Docker container from the injector, from the controller, from the Neoload web. All of that is d'usine, comme on dit en anglais, from the shelf. I think that's the expression. But the configuration is more inside Jenkins. All the job is done in Jenkins. The rest is easy to deploy and to use. So we have not so much work do on Neoload different components. Which of course we have to adapt the parts of the disk access in Docker, etc. But that's the job to deploy in a Docker. But the most part of the job is inside the configuration of Jenkins to start the different stage of Jenkins. That's the place we have the most of the job. That's it.
Neoload as a container, or a Docker container that you spin up as an agent. You know, in GrooveScript, you can specify that I'm going to run that task in an agent, and the agent is basically a Jenkins slave plus with Neoload installed, with the Neoload installation. It's avoid this the sharing volumes, because a slave by nature has access to the workspace by default. So that will have saved the configuration part, where you have to make sure that the container that you start have access to the resources that Jenkins is exposing and so on. So that's to make the life easier. I think the agent approach is resolve a lot of small tasks related to making sure that every container has access to the network, the resource, blah, 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 and so on.
There is a question.
No. It was just a note. I'm impressed. I'm impressed by the latency. Okay. By the latency that we have between Marseille.
Yes, we've got some latency at this time.
Yeah, I don't know what, but someone in
because it's raining.
Because I was wondering.
No, I mean Renault. So I mean
the latest TV show.
That's it. No, I'm in Renault Tower, so I can see the Eiffel Tower from here, which is in the fog. So the day is absolutely horrible. So I better spend time here in the Pac-Man all over the world than to be in Paris in the cold raining day. That's it. And thank you for the jacket.
You're welcome. I guess in Liverpool. How is the weather in Liverpool,
Rob? Rainy, cloudy.
I guess we are more lucky than you are. All right. So looking at the watch, so it's if there's any questions, Rob, do you have any more questions?
From me, thank you very much, Bruno.
All right. Thanks, Bruno. Thanks for your presentation.
Welcome.
Great. I see that we have a new. We have our SWAT, the very well-known and popular called Scott More Connected. So, hi Scott. Pretty sure it's morning time for you. Hey. I don't see the. I don't see the jacket.
Sure everything works. Sorry.
I don't see your jacket. It's a shame.
Not yet. It's coming. I'm at work. But I'll be changing soon into my Marty McFly uniform, I promise.
Okay, cool. All right, so let's have a short break.